Alright, today we're going on day 3, 14.5. We're looking at polar coordinates and conversions. So we want to understand the polar coordinate system, how to plot points, convert from polar to rectangular, and rectangular to polar. So we're going to have a few new terms, but actually most of what we're going to do here is stuff that we know from trig already. So first, the pole. What is the pole? The pole is a fixed point. So fixed point. Think of the origin as a pole, for example. The polar axis is an initial ray from the pole. And then polar coordinates are written as r comma theta. So let's look at a picture of this. So this would be like your x and y, but instead of x and y we have r theta. So here's a pole. This would then be the polar axis. We have polar coordinates r theta. So for example, if O is our pole and this is our polar axis, this would be our angle theta, and this would be the distance r. So then we have a point P, which can be represented as r comma theta. So r is a directed distance, so positive or negative of the point from the pole, and theta is the angle from the polar axis to OP. So one thing to point out, r can be negative. Also theta could be negative. Think about negative angles when we were dealing with trig. And what do negative angles do? Well, negative angles go clockwise, positive angles go counterclockwise. So, if we want to plot the point and find 3 additional polar representations of the point between negative 2 pi and 2 pi. So we'll do a few of these together, and then I'll have you do a few on your own. So first let's plot the point. Well, where is 2 comma 3 pi fourths? First, where is 3 pi fourths? So 3 pi fourths is in the second quadrant, and if I draw, let's say that's 1, let's say that's 2, so 2, 3 pi fourths is going to be approximately here. Now we also want to come up with 3 other representations of the same point. So if this is 2 positive 3 pi fourths, I could also write this as negative 2, 2 comma negative 5 pi fourths. How else can we represent this? Well, now we're going to have to use negative angles. So what is opposite 3 pi fourths? Well, 7 pi fourths is opposite 3 pi fourths. So this can also be represented as negative 2 comma 7 pi fourths. Because if I'm at 7 pi fourths, but then I use a negative r value, that jumps me across the pole or the origin. So I'd be at 2 comma 3 pi fourths. And then my last representation between negative 2 pi and 2 pi would be negative 2 comma negative pi fourths. So all 4 of these representations, or of these polar coordinates, are the same location between negative 2 pi and 2 pi. Obviously, if we go outside of this domain, then we're going to have many other options. So let's try this again together. So what about 5 root 2 comma 11 pi, or negative 11 pi sixths? So first, where is negative 11 pi sixths? Well, that's going to be in our first quadrant, somewhere around here, and so I'm going to say this is the point 5 root 2 comma negative 11 pi sixth. So now what are some other representations of that? Well, I could do 5 root 2 comma pi sixth. What else can I do? Well, opposite pi sixth is 7 pi sixth, so I can do negative 5 root 2 comma 7 pi sixth. And then I could also do negative 5 root 2 comma negative 5 pi sixth. So again, all four of those are the same location. Now I want you to try. So plot this point and find 3 additional points between negative 2 pi and 2 pi. Pause the video, unpause when you're ready to check. Okay, so this one's kind of a trick question. Depends on what you think of as a trick, I guess. I mean, this is not like a card trick, which actually is not a trick either because that's magic and we all know that. But there's a lot of different answers for this, because if we have a radius of 0, then we're actually talking about the origin, so the angle does not affect the location of this at all. It's just going to be at our pole, or our origin in this case. So if I want to write this in other representations, as long as I make the radius 0, I can use any angle I want between negative 2 pi and 2 pi, since that was my restriction. So there's many correct answers. In fact, there's an infinite amount of correct answers. Alright, next thing we're going to look at is how to convert from polar to rectangular and rectangular to polar. So first, how do we go from polar to rectangular? Well, this is from our relationship between the rectangle coordinates and our trig functions. So I know that cosine theta equals adjacent over hypotenuse, which is x over r. Therefore, x equals r cosine theta. And using a similar idea, I know sine of theta equals opposite over hypotenuse, which is y over r. Therefore, y equals r sine theta. So this is how I can convert from polar to rectangular. X is r cosine theta, y is r sine theta. What about going in the other direction? So from rectangular to polar, well, I know x squared plus y squared equals r squared, and I know tangent of theta is y over x. There are other relationships that I know as well, so you don't have to use tangent, but this is the main relationship between directly y and x. Obviously, if you know r, then you could use sine or cosine as well. So, I want you to convert the following to rectangular. Pause the video, unpause when you're ready to check your work. Alright, for the first one we should get the point 0, 16, and for the second one we should get the point 0, 3. Here is the work for that if you're confused. So I know x equals 16 cosine of 5 pi halves. Cosine of 5 pi halves is 0, so 16 times 0 is 0. Y is 16 times the sine of 5 pi halves. The sine of 5 pi halves is 1. 16 times 1 is 16. Similar situation for the second example. X equals negative 3 cosine of negative pi halves. The cosine of negative pi halves is 0 again, so x equals 0. Y equals negative 3 sine of negative pi halves. The sine of negative pi halves is negative 1. Negative 3 times negative 1 is 3, so y equals 3. Let's try to go the other direction. So now I want you to convert the following to polar between 0 and 2 pi. Pause the video, unpause when you're ready to check your work. Okay, so for the first one here, I want to recognize that negative 3 is in quadrant 3. That's going to be important when I find theta. Finding r, I can recognize that this would actually just be a 45, 45, 90 triangle, so it's going to be 3 root 2, or I can use the Pythagorean theorem. Either way, r comes out to be positive 3 root 2. For the first example, or for the first part. I know, again, I can recognize if those two sides are the same, that I'm dealing with a 45-degree angle, but recognizing that it's in quadrant 3 means that theta is going to be 5 pi over 4. So the most straightforward answer is 3 root 2 comma 5 pi over 4. However, because the only restriction was between 0 and 2 pi, I could also use negative 3 root 2 comma pi over 4. So either of these would be correct. You do not need both because it did not specify all answers. It just said find an answer. So then for the second one, I only found one answer because it's not a nice angle. We could find two though. But I know that this is going to be a 5, 12, 13 triangle, so R is going to be 13. Also, again, recognizing that 5, 12 is in the first quadrant. So that theta is going to be the tangent inverse of 12 over 5. I know that I can leave my answer in this form because that will be a positive angle between 0 and 2 pi, specifically in the first quadrant. So I can leave my answer as 13 comma tangent inverse of 12 over 5. I did not specify, so you could also type this into your calculator as well. Next, we want to look at converting the rectangular equations to polar form in terms of r and theta. If it's possible, we want to solve for r. So, for example, if I have y equals 3, well, I know y is what? Y is r sine of theta. So I know r sine theta equals 3. So now if I want to solve for r, if possible, and it's possible in this case, I could rewrite this as r equals 3 over sine of theta, or 3 cosecant of theta. So I want you to try and use the conversions that you know to write this rectangular equation in polar form and to write this rectangular equation in polar form. Pause the video, unpause when you're ready to check your work. Alright, for the first one here, substitute in for x, r cosine theta, y is r sine theta. Now remember I said if possible you want to solve for r, so in this case we can. So we can factor out an r, and we get r times 3 cosine theta plus 5 sine theta equals 2, divide by 3 cosine theta, 5 sine theta, so r equals 2 over 3 cosine theta plus 5 sine theta. For the next one, here, x squared plus y squared is r squared, y is r sine theta. Factor out an r again, and now I can set each one of these equal to 0 to solve for r. So I know either r equals 0 or r equals 8 sine theta. So in this case I actually have two different equations for r from the single rectangular relationship. Let's try to go the other direction. So now I want you to convert the polar equation to rectangular form in terms of x and y, and if it's a function, solve for y. So, for example, if theta equals 11 pi sixths, then remember I know tangent of 11 pi sixths equals y over x. Well, what's the tangent of 11 pi sixths? So now using my unit circle, I know negative root 3 over 3 equals y over x. So now if I solve for y, then I know y equals negative root 3 over 3x. So what is that? That is the equation of a line. So now I want you to pause the video and convert the other two. Unpause when you're ready to check your work. Okay, for the second one here, r equals secant theta. Secant is 1 over cosine, so r cosine theta equals 1, therefore x equals 1. That is a vertical line. The next one, this is not going to be a function. So first, we want to change sine of 2 theta. We don't like the 2 theta, so I know 2 sine theta cosine theta is sine of 2 theta. Sine of theta is y over r, cosine of theta is x over r. So this is r squared, so I end up with r to the 4th equals 2yx. Well, r to the 4th is x squared plus y squared quantity squared. This is not a function, leave it like that. Here's our conclusion. Know how to convert from polar to rectangle and rectangular to polar. Good stuff.